In this video, I'm going to be talking about Nrf2 and KEAP1 or KEAP1. So KEAP1, it pretty much holds Nrf2 hostage. I'll also be explaining how magnesium helps open up the escape routes for an Nrf2 to escape the being held hostage by KEAP1. Okay, so this goes to show that excessive or extreme selenium can be a bad thing, and Brazil nuts are really full and packed of selenium. And the reason for this is because of a thing called TRXR, and if that is overactive, that actually leads to KEAP1 cysteine saturation and then suppressing Nrf2. Now, Nrf2 is needed to reduce advanced glycation end products, because if there's too much excessive AGEs or advanced glycation end products, one of the serious health effects or issues from excessive AGEs, is that the ECM, or short for extracellular matrix, becomes way too rigid that immune cells and T cells, they cannot go in and attack cancer cells. So basically, the downstream effects of TRXR overactivity is that, so KEAP1 has these cysteines, and if they become saturated, that means that Nrf2 cannot cycle. What this does is that there's an accumulation of carbonyl stress. So carbonyls are basically compounds or constituents of AGEs or advanced glycation end products. Another issue with this, in combination with rigid ECM, where immune cells can't go in to attack cancer cells. So another issue combined with that is that there is also a recruitment of Tregs or Tregs. And what Tregs will do is that they steal IL-2 from T cells, making them weak. So that's a double negative for the immune system. First, the immune cells can't go in to attack cancer cells because the ECM is rigid, and the cancer cells are too weak to fight cancer cells because of IL-2 stolen from them by Tregs. Okay, now there are some foods that can actually activate Nrf2. So some of them are crucifers, such as broccoli, cabbage, radish, onion, garlic, low zinc polyphenols, such as berries and red cabbage. Also, glycine-rich foods, such as collagen and gelatin. So gelatin can be found in bone broth. And then also, these are moderate sulfur donors, or possibly even sulfur supplements could help. So basically, the effects of all of those foods that I just mentioned is that it enables Nrf2 being released hostage from KEAP1 or KEAP1. What that ends up doing is that it's more likely to reduce carbonyl stress caused by advanced glycation end products, therefore reducing Tregs so that the IL-2 is not stolen away from T cells, because that's what Tregs do. Also, cancer and tumors, they recruit Tregs to steal IL-2. So that goes to show that KEAP1, by holding Nrf2 hostage, that promotes or enables an M2 phenotype, which pretty much what protects and supports tumors. So KEAP1 holding Nrf2 hostage is supposed to be for autoimmunity. But in that state, the Tregs steal IL-2 from T cells, making them weak, and then that's how cancer cells thrive and survive, because there's no T cells to fight the cancer cells. So that happens if KEAP1 holds Nrf2 hostage. Okay, so with Nrf2 being released from KEAP1, this supports immune plasticity. Now, KEAP1 holding Nrf2 hostage is not completely totally bad. The reason it does that is to protect against autoimmunity, where the healthily bodily tissues are being attacked and damaged by T cells. So keep one holds Nrf2 hostage so that Tregs are able to be recruited to quell the overactive T cells to protect the healthy bodily tissue from attack. But if keep one holds Nrf2 hostage for too long, then the T cells will be overly quelled, or there won't be enough T cells to attack cancer cells because Tregs are suppressing the T cells. Therefore, the cancer survives. So keep one Nrf2 coupling or axis is a double-edged sword. Okay, so this next piece with magnesium is super critical and important because even if keep one was to release Nrf2 from hostage, or from being held hostage, then the Nrf2 will still stay cytosolic. So what magnesium does is that it enables the activation, and these are magnesium dependent, of AMPK as well as PKC. So those require ATP from magnesium. So these phosphorylate Nrf2 so that it can enter into the nucleus. Okay, so TRXR, as I said at the start of the video, enables keep one to hold an Nrf2 hostage. But magnesium actually re-enables the redox oscillation that the TRXR dominance is trying to flatten. Okay, so another issue with excessive or too much selenium from, let's say, Brazil nuts is that it prevents immunogenic age alarms because advanced glycation end products, it's pretty much another way to say it is acetyl CoA, and the immune system actually benefits from acetyl CoA. But too much selenium, which tumors actually prefer a selenium rich environment, as too much actually prevents that acetyl CoA signaling to the immune system. Because if the immune system got that signal, then that would provoke an immune attack on the tumor or cancer cells. And that's why tumors prefer the selenium-rich environment to suppress the immune signal. So another issue with tumors thriving in selenium-rich environments is that it allows damaged proteins to persist silently, because proteins, they get damaged when protein and glucose are combined together. There are some arguments that it's not really the case, yet some people tout it and push it out that advanced glycation end products are a result of damaged protein combined with high glucose. So it's an ongoing debate. Another critical benefit and function of magnesium is that it repairs the membrane at lysosomal membrane if it's peroxidized. The reason that's important is because if the lysosomal membrane is not repaired, what happens is that cathepsins, they leak out, because cathepsins are supposed to stay in the lysosome if the membrane is not peroxidized. Because if the cathepsins are in the lysosome, the cathepsins can degrade exosomes so that the tumors do not receive the exosomes. Because if they do, then the tumors can wreak a lot of havoc on the body with the exosomes. Okay, so quick recap. TRXR dominance allows keep one to hold Nrf2 hostage. That's not really totally bad, because keeping Nrf2 hostage prevents autoimmune attack on the body. But if it's held for too long by keep one, Nrf2 cannot allow T cells to attack cancer cells and cannot open up stiff, rigid ECM because of advanced glycation end products. Also, tumors thrive in selenium-rich environments because selenium suppresses immune function by acetyl CoA. So that's it for the video. Keep it locked in here on this channel, subscribe, and I'll see you in the next video.